for 8.5 day 2, I want to start off by doing number 1 and 2 as a warm-up. So please pause your video and take a look at those. You do need to understand how to do that before you get into today's stuff. So for number 1, we are working on expanding here. So we're going to have log base 5 of 3. Then we can throw the 6 out in front and have log base 5 of x. Then we would subtract log base 5 of y because it's in the denominator. And then we would subtract 2 log base 5 of z. If we go the other route with condensing, we would have log base 2 of 5 and then x. And then we would have w to the 9th in the denominator because it's a minus, and we would throw the 9 up top. So number 3 starts showing us what we are doing for the day. Okay, so there are a bunch of different options, okay? And this is something that you've seen before. And remember, anytime you have a log on both sides, essentially you just drop them. The thing is, though, I want you to continue to get in the habit of just putting it as base and then whatever that log base is. So essentially, we're making both sides base 2, which is what's canceling it. So now we have 2x minus 1 equals x plus 5. If we move x over, we get x. And if we add 1, we get 6. Now, again, you always want to make sure that your domains up here stay positive. And they do if we plug in 6. Okay, so again, you're still focusing on the exponentiating both sides. Okay, because you have to do that regardless. That's why they cancel. All right, so we are looking at the next one. Okay, another step has been added to the beginning. Then follow the steps shown in the example above. Note that you will have to solve a quadratic equation here. Okay, it is factorable. So what's being added to this is that sometimes you have to either condense or collapse, in other words, or sometimes, you'll have to always condense. You won't expand because you don't want to make it larger to then try to solve. Okay, so that's the only step that's being added here. So if you look at number 4, the only thing that you can condense is to take the 2 and throw it up top. So now we have log base 5 on both sides, which means if we exponentiate both sides, we're left with x minus 3 squared equals x plus 27. Now, big thing, we talk about this all the time. You have to FOIL that. Okay, we are FOILing here. If you FOIL correctly, you'd get x squared minus 6x plus 9. And it's still going to equal x plus 27. At this point, we do need to get everything to one side. So let's move it to the left. We get x squared minus 7x minus 9 minus 27 is 18. And then we would t-chart this. First times last is negative 18. And we would use negative 9 and 2 because that multiplies to negative 18, adds to the negative 7. So we can rewrite this as x minus 9 and x plus 2, which makes x 9 and negative 2. Again, we always want to check to make sure that these work. If we plug in negative 2, our first domain up here would end up being negative. Right? But the problem is we are squaring it. So it would be negative 5 squared, which is a positive 25. So that one works as well. So we're going to solve a logarithmic equation by exponentiating. So this time, if you notice, there is not a log on both sides. So because that is not true, what we have to do is just condense it, and then we're going to exponentiate just like we have been. But it's just not going to cancel both our logs. So in other words, let's combine these, right? So if we condense them, because there's a plus, that means that we are multiplying. So log base 10 of 5x times x minus 1 equals 2. So again, we are going to exponentiate both sides, or you can think about it as the Hart method. That's fine. So we get 5x times x minus 1 equals 10 squared, which is 100. And we solve for x. Distribute, and we get 5x squared minus 5x equals 100. But I'm going to subtract 100 over so we can start factoring. If we take out a 5, we're left with x squared minus x minus 20. And we can t-chart with 20. We get negative 4 and 3. So 5 times x minus 4 times x plus 3, which makes x 4 and negative 3. So at this point, we do need to check our answers. And what you want to check is when you're about to start exponentiating. So if we plug in a 4, we would end up with a positive. And if we plug in a negative 3, we would also end up with a positive. So both of those end up working. So we're just going to have some mixed examples. Feel free to try them before you watch me do it. We just have these 4. Okay, so I am going to go somewhat fast with these, so feel free to pause and try them on your own first. So this first one, we have to condense first. You cannot drop logs as when there's more than 2. There needs to be 1 on each side in order to drop them. So I don't want you to think about dropping them right away. Okay, we want to make sure that we have everything condensed if we can, because if we can, we should. Okay, so on this one, it would be log base 4 of 48 divided by x, because it's a subtraction, right? At this point, when you exponentiate, the log base 4s go away. We're left with 48 over x equals 6. So essentially what I would do is multiply by x to get it to the other side. So now we have 48 equals 6x, which means we divide by 6, and x is 8. If we plug in 8, we are good to go. Number 7, again, we are going to condense it first because we have 2 logs on one side, and anytime you have that, you want to condense it first. So for this one, there's a plus between them, which means we are going to multiply. And now we exponentiate both sides. So we have x times x minus 9 equals 36, or 6 squared. So we have x squared minus 9x, and I'm going to subtract 36 over. So we have 36, and we need to negative 36, and we need to get to 9. Well, obviously it's not 6 and 6. It is 12 and 3. And because it's a negative 9, it's going to be a negative 12. And if we solve for each, we get a positive 12 and negative 3. Last 2. On number 8, the left side, I notice that I can pull that 2 up. So we have log base 7 of x squared. On the other one, we can combine these to be log base 7 of 27 times 3. So when we exponentiate both sides, we get x squared equals 81, because 27 times 3 is 81. Square root both sides, and x equals plus or minus 9. Now again, you might not have remembered that it's a plus or minus. The minus doesn't work anyway because we have a, oh, actually it does. It does work. So it should be plus or minus. Because that does work because we're really talking about x squared, not just x. And negative 9 squared is positive 81. On number 9, our last one, we're going to combine these two, and we get log base 3 of 2x times 7. And it equals log base 3 of 35. Now we can exponentiate both sides. We're left with 2x times 7, or 14x, equals 35. And if we divide by 14, we get 2.5. Or 5 halves, if you want to keep it that way.